Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
It is simply a great pleasure for me to introduce Chip to you. I've known Chip for quite a while. His reputation in the community is that he's one of the topmost engineers in our entire field, and he's obviously very well known. He's got many awards that I can't even remember. I remember a few years ago he got this award at SIGCOMM, which was quite interesting. Some of you guys who were at SIGCOMM might remember, because I don't remember it, and he wouldn't tell me, because he didn't want me to talk about it. It was the Nobel Prize of SIGCOMM or whatever. But anyway, so bottom line, Chip is now actually heading GENI in a way. He's sort of the main guy now, who's kind of going to be going around and sort of talking about GENI, as well as sort of deciding what sort of things gets funded and how we're going to build this thing up. So I invited him over to talk to us a little bit about what his vision is and the community's vision is and where they want to go with it. So, Chip.
Thank you, Victor. Well, thank you very much for the invitation, actually. Not only is Victor an old buddy of mine, but kind of a pillar of the community, so thank you very much. I come here with a purpose, and the purpose is to try hard to get Microsoft heavily involved in GENI. And so I would like to kind of have a back and forth about if that's possible and how that's possible. So this is not a dry academic lecture. This is an attempt to see, can you get engaged, and if so, what would be a good way to do it? Okay, I have a fair number of slides, but I hope you're a wild audience and are willing to jump in and ask hard questions when they occur to you. Let me begin with a comic book, if I can. And, not quite the comic book. So this is the GENI vision as currently articulated. And I would like to say this is pretty early in the currently articulated process. You'll see it's actually rather different. This makes it look pretty concrete. It's actually the National Lambda Rail backbone you're looking at, and specific NFL cities and so forth. But no matter what GENI is, it's intended to be a facility where people can try out experiments in global networks of the future. And network here is construed very broadly. It's everything that my mom would think is the network. So everything from layer 7 to layer 1, right? All is within. But the core idea of GENI is programmability. So researchers will be able to allocate parts of the network, pour their software in, run experiments, and so on. And I'll get into this quite a bit more as we go in. But let me begin with two short comic books. And I don't mean to insult anyone's intelligence, but if I do these kind of quickly, then I think this gives a basic orientation as to what is GENI. So let's imagine that GENI already exists. How would we use it? Well, here we have a researcher, and the researcher has a really bright idea. And this particular researcher's really bright idea is that, hey, the internet was all designed to connect one computer to another, but nobody cares about that anymore. Right? We all have hundreds of CPUs for each one of us. All we really care about is us and content. So everything should be just re-architected completely so it's based on people and content. And I think you may have heard talks like this before. The peanut gallery here says, yeah. But we're now kind of in GENI land, so you have to project yourselves a couple of years into the future. And so he tries out a little something in his lab on his 1 or 2 computers, and boy, that doesn't seem to crash too often. So he gets granted a slice of GENI. And here we've shown he has some backbone router / data storage type things, maybe some storage clusters, what have you. And maybe he has a good chunk of the wireless spectrum in Seattle and some over here, wherever that is, Atlanta, I'm not sure. And he pours in his software into this part of GENI, this slice that he's been allocated, and starts running it end to end. And along the way, he publishes papers, which of course is what professors like to do. And it turns out, well, that first idea wasn't exactly a great idea, but it mutated once and it mutated again. And after it mutated a couple times, it was some sort of location-based social networking service that he has up and running. And as this gets to be a more and more popular service, first of all, real users can opt in. So real people in the GENI vision can start to participate in these long-running GENI experiments. And the experiments might go on for months or years. This is not an afternoon's experiment. You know, he may get this thing up and running. Real users begin to opt in. And his chunk of GENI, his slice of GENI, he'll be given more and more of this facility, assuming this is a really good experiment. It seems to have some traction. Now, he's not getting all of GENI, right? There's a lot of other stuff going on. But his part of GENI may be getting bigger and bigger. So this particular story ends, it turns out, well, it turns out this wasn't incompatible with the internet after all. You know, he finally had the insight he was going for. He migrated off GENI onto the internet, and away he went. But meanwhile, there's a number of other researchers who are doing actually rather different kinds of research on GENI at the same time. For example, making a very highly available version of the network, or having lots and lots of live sensor feeds in people's lives, and so on. Okay, so GENI is supposed to enable these kinds of research, and they will go on simultaneously in these fairly big networks. Okay, so here's the moral of this little comic book. So GENI is supposed to enable trials of new architectures with long-running, realistic experiments, by the way, instrumented, something that's been a little bit lacking in most network research, with real users able to opt into these experiments, and a path by which successful experiments can be transitioned out of GENI and into reality. But GENI itself is not an experiment. The GENI facility has to be a stable facility on which people can run experiments for years. So it has to be pretty reliable, pretty robust, just keep working. Okay, so that is, if we had GENI, how might we use it? Yes. Bless you. Bless you.
I'll start. Perhaps I misunderstood. I thought an idea behind GENI, only based on what you said so far, is if you're going to put something around the country with huge capacity and a lot of distances, then obviously you're looking at things where inherently the problem has to be scale or distance, I'm thinking. But you didn't say that in your summary. Did I miss something?
I believe the core idea of GENI, where it's really going to have high payoff, are things that are scalable so that you could roll it out for real global problems. However, there are going to be many grad students who actually use it for relatively modest things. Right, but I do believe that's the real sweet spot for GENI, is trying to do new architectures that really could be global architectures.
So in a sense, you're leaving a lot of room for serendipity.
Oh, you'll see. There's trying to predict, even 3 years in the future is pretty hard.
I can't predict lunch.
Right. I think I had lunch.
What is the stable layer?
The stable layer in all this?
Yeah.
Yep.
You said for these experiments, it can't be flaky, it has to be stable.
Right.
What is that stable platform?
Okay, so you will see later on in the technical parts of the talk, GENI is envisioned as being a control framework, operational framework, and various substrates. So the control framework and the operations system must be very stable. In addition, the substrates have to be stable enough so that they support long-running experiments. It may be clearer, the answer to that later. Maybe not. I mean, if you can remember the question, let's... Okay, second comic book, and then we'll get into everybody's favorite of programmatics. So if you stop and think, yeah. That's correct.
And nowhere in your initial bullet points I saw things, lessons learned from Planet Labs and things we would
Right.
do that are similar to Planet Lab, but the things we'll avoid that Planet Lab didn't get.
Right. Yeah, Planet Lab is I think, a great success and a highly influential facility. And I imagine Planet Lab will continue to grow. Planet Lab has very strongly shaped GENI. Larry Peterson, who's Planet Lab's founder, is also one of the ringleaders in GENI. One way to look at GENI, and I think this is a kind of a restricted way, but one way to look at GENI is to take a Planet Lab notion and extend it greatly so that virtual machines occur at many, many different places and levels, in layer 2, in, quote, routers, and so forth. Okay, so it's the notion of user-loadable virtual machines in many, many different parts of what we think of as a network today. Another way to think of it is Planet Lab with ways of giving, say, wireless connectivity, defined optical connectivity, and so on. Okay, well, if you stop and think, which hopefully nobody stops long enough to think, but if you do, this notion that somehow you're going to build a facility where you can try out the way networks are going to be 10 to 20 years from now is kind of an ambitious goal, right? I mean, I think if we think in kind of vague terms, we imagine that global networks 10 to 20 years from now probably have CPUs. They probably have storage of some sort. They probably have connectivity. Probably wireless will still be a very important way, probably even more important way for people to interact with the network. Right? But this is kind of a tall undertaking to predict what we're all going to be doing 20 years from now and build a facility to support it. So if that were the plan, I think that would be a kind of a poor plan. So really, and in fact, a lot of the academic community has had quite a bit of trouble with this particular point. The conceptual stage of GENI came up with a point solution, which I think would very rapidly become obsolete. So I think we have to get away from point solutions and head more towards things that actually have upgrade paths and will survive for a long time, say 10 to 20 years. So we have basically two ways that we intend to attack building the GENI, designing and building the GENI facility. And this is kind of the miracle of buzzwords, but one is spiral development, and the other is federation. And so I'll spend a minute on each of those. Spiral development, I think, is familiar to all of us in the software or the big systems business, whether we use the word or not. And that is, if you think you want to be kind of way over there some years from now, but really it's pretty murky what way over there means, you should do something within, say, 6 to 12 months that you understand, use that for a while to gain a better understanding of what you want, and then go from there, and so on. And I think this is a very important part of GENI, is that we should start now, i.e. 6 to 12 months from now, we should have a proto-GENI, the first proto-GENI up and running. Because then we will be able to start thinking. With nothing, it's very, very hard to think. So we should get started immediately with things we can grasp and use that to start forcing the design and getting people to agree and to move forward on where we're really going. Okay, the other important technique is federation. And this is, GENI is not kind of the monolithic GENI or the Soviet GENI, one central organization designs, builds, and operates GENI. It's much more along the internet lines, where there are different parts of GENI which are built and operated by different organizations, and that probably use quite different technologies in them. So for example, we hope right off the bat to have multiple different kinds of computing clusters in GENI, not just one kind. We hope to have multiple different optical networks, probably switched optical networks using different technologies within 6 to 12 months. And wireless, which is a perennial thorn in everybody's side, will probably begin with things like Wi-Fi, WiMAX, and cellular in the near term, 6 to 12 months, but keep migrating as these technologies change. So we'll start with technologies we can actually build today, but the plan is, as new technologies become available, we'll create, say, a city of that technology and federate it into GENI. So that's how we're going to handle technological evolution. In addition, various other nations are busy building things that are kind of at least recognizably near the GENI space. Japan, the European Union, probably China, are building things like this. And it is plausible to think about federating the NSF, the American part of GENI, with these other national GENIs, or whatever they are. Finally, there may well be corporate GENI facilities. For example, it may be useful for companies to set up experimental infrastructure and operate it for their own uses and control it themselves. They may want to federate into the public GENI and allow some of those resources to be used by academic researchers or say, for profit, either way. Right? So we would like to structure it so all these different things are possible. Yep.
If I'm leading the witness, you can postpone the answer for your slide. You know, when the internet first got started, 69 to 73-ish, one of the problems was it worked so well, so fast, it got in the way of the research agenda.
Right.
So there was an interconnect and a pure research agenda. That was tension. It worked well, but it was there. So it seems to me that if you're going to use a federated approach, the envelope is defined by, if it's inside GENI, it's experimental, we can make mistakes, and the outside is it's operational and so on. But is there more to it than that? I mean, are you going to have tension between it starts getting useful? And in general, what is the envelope between GENI or not GENI, if there are
Right.
federations we're playing?
Well, so federation, we're trying to use federation as a way to, a possible success scenario is that someone actually makes an experiment that's useful, right? And that starts having, say, hundreds of thousands of real users, and by the way, they're willing to pay. Well, what do we do now? We would like to have a way of kind of weaning that experiment off the NSF part of GENI and on to some commercial part of GENI while not shutting down the NSF part, right? We want to move that experiment out to commercial land.
Is that a to be done, or has there already been some thinking about the formula for doing that?
There's the very first thinking, right? This is really early, and so if you have a plan, type it up. Okay, so this one I hope is preaching to the choir. Rather than try to predict 20 years in the future and then we'll build for the next couple of years and then use it for 15 years after that. No, we're not going to do that. Right? We're going to do it in a rational way. I'm not going to bother to read this slide aloud, but the important part, I think, for this crowd is that we would like rapid prototyping to begin now. In fact, we hope to put out a solicitation for proposals in mid-December. And so one of my goals here is to try to get you to respond to that solicitation. So we hope in 6 to 12 months, the very first parts of GENI are kind of struggling to life. This will be in prototype form, right? So it doesn't have to work really well at all, but it will allow everybody to think. Okay, a little bit of programmatics. So GENI has been going on for almost 3 years now. These are kind of the core set of founders. There are actually more founders than this, about 100, mostly professors. A little bit of industry participation, not too much, has been what's happening in GENI thus far. They produced kind of a conceptual design of GENI, which I showed on the very first slide, kind of a national footprint and so on. And that's kind of the starting point for what we're doing. But about 6 months ago, GENI entered its second stage, from the early conceptual stage to the let's do the formal planning and then let's start building. And so there are currently 3 major entities: the NSF, which is where the money comes from for this thing, the GENI Science Council, which is drawing up the research plan, primarily an academic group, although it would be really good if they actually had more industry players. And I'm here on behalf of the GENI Project Office, which is the program management and system engineering wing of this. The plan it, build it, operate it wing. I think probably some of you know some of these people. In particular, Aaron Falk is the head of the Internet Research Task Force, the IRTF. Kristen Rauschenbach is pretty well known in the optical switch world. She did a very high-end optical switch in a fairly big startup. Craig Partridge is a well-known internet research guy. Heidi Dempsey has done operations for some of the major Verizon services, like introducing virtual private networks and voice over IP as services. So she's in the operations side of this. Here's the timeline that we're currently operating under. We've just about a few, maybe 4 or 5 months ago, I guess 6 months ago, began the planning phase. So notionally, the planning phase will go on for 3 or 4 years. In terms of funding level, this will show you kind of the level of effort. The NSF is putting in about $7.5 million a year for prototyping in this phase. Right? So we're going to be building prototypes, and that's not a lot of money. If you think, I want a lot of technologies, and actually I want competing groups in every technology, well, you start dividing 7.5 million by too much, basically. So we are very much looking for industrial contributions, not just from you guys, but from everybody. Yep.
I think it's the case that in NSF panels or something, if a industrial partner asks for money, it's a kiss of death for the whole process.
Okay, this particular one, that's a great question. This particular one, we have worked very hard that our preferred teams in this planning phase, but not required, but preferred, are joint academic industrial teams. Typical industrial overhead is allowed, profit is allowed, all that is allowed if you care to bid it. Now, we are going to procure on a best value basis. So the more you can shave the cost and up what you're giving, the more competitive you are. But this is open to for-profit companies, and you'll see that's kind of a thread going through this whole thing. We would like to encourage for-profit industry to participate.
If I can be a really tough cookie, can you back up to the list of names? One more back. Yeah. All academics?
I think, if I remember right, there's one non-academic.
Maybe you can fix that. Go back and add some boundaries. It's just a thought, right? Because I think it's to that point. Right. But I've done a lot of, people here have done a lot of NSF funded stuff, but we never ask for money because we know it won't be funded.
Right. So, but let me be very clear. So you would be asking us for money, not the NSF. Right. This is a GENI project office solicitation, not an NSF solicitation. And I am telling you verbally, and you'll see later on, I'm telling you, for-profit companies, yes, we will give a subcontract to you and we will pay you. Certainly as we enter the construction phase, we firmly expect that all to be for-profit and to be paid. Now, predicting the future is always difficult, right? But we have worked hard, and that's the way things are. Yep.
So at the end of the planning phase, do you expect to have a prototype GENI, or do you expect to have just like a very detailed application?
Yeah, you'll see in a second. The answer is, yeah, we expect to have a prototype GENI. Yeah. Okay, so here goes the planning phase. Notionally, 3 or 4 years of planning. Very notionally, a construction phase followed by an operations phase. Personally, that's the way the NSF likes to do large projects. Think of a radio telescope or something. You build it and then you use it. I think in the computer world, that really doesn't make very much sense. So one of our battles, the GENI project office, is to try to get specific parts of the NSF to agree that operations and construction actually overlap. Yep. We would love to do things quicker, but I think it's unlikely, right? I think we're just in budgetary terms. The easiest way to understand this is there's probably 3 to 4 years of $7.5 million a year, followed by some years of about 10 times that amount of money per year. We would.
When do you restart the funding phase to do your spiral?
Okay, so we would like personally, we would like the spiral development to go on all the way through this process. I think most computer people would prefer that. We are fighting bureaucratic battles with NSF where they like to have a complete blueprint and then build and operate. Okay, but I think rationally you would continue to develop the way all of us do when we develop big systems.
If I can add a voice to it, this strikes me as a huge gotcha.
Yeah.
And I sense that you're more than sympathetic with that. We're on the same side on this issue, but just to reiterate, everything I ever saw in internet development has always been progressive refinements and backup sometimes, and lots of practice interleaved with lots of confusing theory. And I can't imagine that a 5-year construction phase can succeed. Number one, 5 years is going to be 3 years late from whatever their start date was. And boy, 5 years waiting for people to start learning what's going on. Is there something we can shoot in Washington?
I wouldn't shoot. I really think the thing to do is, look, let's do a great job on the next couple years, and this will all play out pretty nicely, right? But that is one of the things on our to-do list, is to get a nice rational plan going forward. Okay, during the planning phase, we are having, yep.
The last comment I have to ask, so are you, is the underlying thing that you're saying is that this program's on probation?
All programs are in probation, right. What's going to happen is, so that the planning phase, the money is there, it's budgeted, that's just, in essence, money in the bank. What happens at the end, you go through a series of these kind of big exams. The conceptual design review, the preliminary design review, the final design review. If you pass your final design review, then NSF will recommend to Congress that Congress allocate money to build and operate.
So this is very different from what was before you took it over, right? Initially it was going to be, my understanding was that you were actually going to go to Congress, or this whole thing would go to Congress and they would say, give us $500 million or something and we'll build it. But that's gone. So what's going to happen now is you're going to...
The plan actually has always been the same, but various people who have spoken about the plan actually did not know the way this mechanism works. All right? But the real mechanism is, and it's to me it's a very sensible mechanism. You get to the point where somebody can make a decision, is $300 to $500 million investment justified or is it not? Do these guys know what they're doing, or is this going to be a horror show? And then they say, okay. And to me, that's a very rational way to do this.
But the Hubble, for example, was not done this way, right?
Well, the Hubble was, I don't know actually how the Hubble was done. Okay, I wouldn't get too bent out of shape about the process, except to realize we're in about 3 to 4 years in which there's funding at, say, a notional $7.5 million a year. We're scurrying around trying to get more money, right? That's one of our many jobs. So we'd like it to be more than that. But that's the kind of thing that's going to be happening. And every 4 months, there's a GENI engineering conference where we can all kind of tune in if we care to, see how GENI is doing, look at all the prototypes, look at the state of the design, and figure out, okay, what's bad, what's good. Then we also have the more bureaucratic process we have to go through of actual design reviews and so on. Okay, I think this is pretty much, yeah. Oh.
Just curious, how does this compare? I'm just going back to the Planet Lab. How does this compare to how the Planet Lab was done? And there was never any big ask of money.
Right.
From NSF, I remember.
Right. Yeah, Planet Lab has, in essence, always, it hasn't followed this trajectory towards a very large sum of money. It could, but it never has followed that trajectory. And so it's kind of getting continual small sums of money.
Sort of along the same lines, how does this compare to, say, Internet 2?
I don't know how they got funded. I don't know. Right. Oh, you'd better ask the psychiatrist what's going to happen to Internet 2. They've been having prolonged wrangles in their merger with National Lambda Rail. So I don't know. I'm sure the facilities will continue to exist. What happens to all the people, I don't know. Okay. The way we're going to measure, this is almost a programmatic detail, but the way we're going to measure readiness for parts of GENI is a NASA-invented thing, technology readiness levels, which if you haven't run into them, they're actually a very good rough justice. And here's kind of a GENIized version of them. Basically, technology readiness level 1 means somebody has made PowerPoint. Technology readiness 9 means we've been using it for 30 years and it works great. And there's kind of all kinds of things in between. If you look at most of GENI, well, there's parts actually that really haven't even appeared in PowerPoint, right? So it's somewhere, most of it is between TRL 2 and 4. So what we want to do is by the time we go to our final design review and ask for a lot of money, we want to have all of GENI at TRL 7. So we want to go to them and say, not only, hey, have we got great paper plans, but look, we have a working prototype of everything that we're going to ask for a lot of money for. It's a prototype, right? It's not the real system, but is a working prototype of that whole thing. So that's what's going to drive our spending on prototyping. So here's kind of...
Is prototyping for the network or also for some of these applications being built?
Not the experiments, right? There actually are separate NSF programs for experiments. So we are not funding experiments.
But probably your success is going to depend on having a couple of...
It would be really, really nice, right? Having a large facility turning over quietly with nothing happening. Too many facilities have had that fate. That's right. Right. Okay, so here's kind of how we are proceeding programmatically through the next 3 to 4 years in the planning phase. In essence, the NSF process is the process of creating paper, right? It is creating design documents and very detailed schedules, monetary estimates, and so on. So by the time we get to the final decision point, we better have all our paperwork in order. Anyone that's ever done a government project, you know, this is very important. In addition, we believe we want a complete prototype GENI at TRL 7. And so what we're going to be doing is figuring out risks, funding prototypes. These odd little shapes, whatever they are actually funding people doing integrations and trials. So we don't expect that we're going to be doing the integrations, but we know there are organizations out there that really like to do this, and they will be doing integrations and trials of various prototypes. Try putting them together. Try operating them. How hard is it to operate this part of GENI? Right? Then we'll be able to get some experience making a basis of estimate for operational costs. Right? So building prototypes, building integrations, trying things out. During this phase, we would like the teams, if possible, to be academic-led. So we will favor joint industrial academic teams where the academics lead during the planning phase. When we get to actual construction, almost certainly that will be industry doing the construction. Not us, you know, but maybe you. I don't think this is your line of business, but you can see if maybe you would do part of it. Because no academic institution is ever going to sign a subcontract that has penalty clauses and so forth. Right? I mean, this is basically build and operate GENI is going to be the thing that comes after this phase. So we'd like to use this time to get industry really up to speed, understand what GENI is, know what's going on, and then flip it and have them get the big contracts. That's why we're encouraging industrial participation now. Okay, here's a couple ground rules. So GENI is going to be built by the academic industrial community, not, for example, BBN. Openness will be emphasized, so designs will be open and so on. Intellectual property is okay. If you want to develop intellectual property under this prototyping, that is fine with us. We do ask, there are 2 licenses that are available. One is, you know, public. Everything I do is completely public, and my competitors can use it for anything they want. The other is, I have intellectual property in this. I will let people use it within the GENI context for no fee, but I reserve all other rights. You're going to have to sign one of those 2 if you want to participate for the stuff that you're doing in GENI. In BBN, we're not bringing any of our favorite technology to this. We're trying to be just completely fair and open-handed. One second. But, you know, there is always never say never, right? I've been doing things long enough. Who knows how the future will go? Maybe somehow we'll do some little bit of GENI ourselves. If so, we'll just put it in the public domain.
Are you referring to the sort of the GENI substrate, or are you referring to the experimental stuff that gets run on top?
Not the experiments. GENI is not an experiment. GENI is a facility. The experiments, NSF has generally had no policy basically about intellectual property. So, and we certainly don't care. But in the facility, either we want you to do stuff that's completely public or to have a license that makes it available for GENI research use in the GENI context for no fee. Okay, the working groups are where technical design is happening. And this is patterned on the early IETF before today's grand, massive IETF. So basically, working groups are expected to create documents, do things mostly through email. Each working group has 1 or 2 chairs, but it also is augmented with a system engineer from the GPO. And the system engineer will be extracting what the working group is saying and writing it down in a series of pretty standardized form industrial documents, requirements documents, high-level design documents, interface documents, and so on. We don't expect the working groups to do that level of detail themselves. Again, the GENI engineering conferences meet every 4 months, hopefully on or near university campuses. And GPO-funded teams will be required to participate. We want to make sure that people come and actually bake the design. I'm going to not read this aloud. Okay, let me get to a system concept of operations. You'll see now you'll see we are very early in the GENI design stage. Despite, if you've ever looked at what the planning group produced, it was probably a yard or so of documentation. But really, the fundamental design is still open in GENI. But this will kind of give you a step through of the parts of the design. There seems to be a kind of a resource discovery part of the design. So here we see a researcher who is asking the GENI Clearinghouse. You'll later see there's multiple clearinghouses in this picture. What resources can I get my hands on for my experiment? And the GENI Clearinghouse says these in some form. Completely undefined what these interfaces are, how this all works. But down at the bottom, there are aggregates which are owned and operated by different entities. So here we have a metro wireless aggregate, which might be municipal or corporate or who knows what. A backbone network, that might be a for-profit company, a service provider, or it might be a non-profit. Compute cluster, maybe we could subcontract, whole bunches of computers and storage from Microsoft or somewhere else. We expect those will be independently owned and operated, and they will publish their information to the clearinghouse.
Is there ever be a fee to use any of these models to the researcher or to the institute? So if I provide a large compute cluster, can I charge X amount of dollars per compute?
One of the major reasons of having clearinghouses, as you'll see, is so that you can have multiple answers to that question. Everybody believes in the NSF part of GENI there will be no charge, and scarcity will be administered by policy. Right? In other words, you get 10, you get 20. We imagine there will be multiple clearinghouses, and some of them will, in fact, charge for resource usage. Okay, so that was kind of a resource discovery. Here's all the things you can do. Then there's a slice creation, and the slice is a virtual cut through this network. So there's a whole bunch of virtual machines, which are these yellow things, and topologies have been created so that these virtual machines can talk to each other. When I say virtual machine, I also mean a slice of the storage facilities as well. Right? So it's kind of a complete virtualization of storage, CPUs, and connectivity. It might be implemented in many different ways, by a literal virtual machine or simply by having a whole bunch of different bare metal machines or what have you. But an important component is the researcher says create a slice, and this configures a topology and gets a whole bunch of kind of blank containers all ready to go. The researcher then puts the code somehow in all these different kinds of containers. And they could be very different. The kind of code that you put in a FPGA is pretty different from the kind of code that you put in, a Linux box or what have you. Right? So it's pretty heterogeneous, this process of installing the code, debugging it, and so on. And then in the experiment cycle, there's the data collection part, the monitoring, all that kind of stuff, by tools to be defined. None of this has been defined yet. Here we see the researcher saying, make that slice bigger. Well, there has to be some control over it, right? Why should I make your slice bigger? Okay, so there's some authority involved as to who gets what resources, whether that's charging or by policy or whatever. And then there needs to be some way to actually grow topologies on the fly. This, to me, is kind of a problematic part of this architectural sketch. I'm not sure exactly how you implement that, but leaving that aside. Okay, now we get to federation. So here, imagine this is the European Union, for example. Or imagine this is a Microsoft clearinghouse, right? Microsoft chooses to make some of its resources available to GENI researchers. Well, probably the way that would happen is by having the NSF GENI Clearinghouse talk to the Microsoft Clearinghouse or European Union Clearinghouse, and they clearly have some agreement between them, right? There's got to be some kind of agreement to make that work. But you can imagine, right, you can start grabbing things around the world, right? And then, oh, by the way, although not always obvious to the researcher, operations and management is always going on. One of the ways that it can suddenly become visible is if an experiment runs out of control and, say, begins to attack the internet or does all kinds of stuff, right? There are all kinds of ways you can misbehave in your experiment. So there needs to be some ongoing monitoring process and a pretty prompt shut it down process. But always, in the background, there's always all the operations and management of figuring out what's broken, when are we going to do upgrades, yada, yada, yada. Again, that happens within this aggregated thing. For example, if the backbone network is provided by Quest or Verizon, GENI, the GPO, is not going to tell Quest or Verizon what operations and management system to use in their network. That's completely unrealistic, right? They're going to use whatever they like using. But we do expect that they somehow interact with a GENI-wide operations and management, at the very least by showing some of the relevant things that are happening to their part of the network. Okay, we're in the last stretch. A little bit of the system overview. You will find, I think, this very unsatisfying, and I would encourage you to start typing, right? This part really needs work. There seem to be researchers in this worldview. The researchers have some kind of tools. Researchers are somehow accredited through research organizations. Who says so-and-so is a graduate student? Who says they're still a graduate student? All that kind of problem happens. So there's kind of the world of researchers. GENI, the clearinghouse, probably doesn't know anything about individual researchers. It really only knows about research organizations. So there's probably a modest level of hierarchy in who is who and the trust and so on. There's probably some sort of measurement plane, control plane, data plane. All this is pretty undefined right now. Aggregates is a set of components controlled as a whole. So it could be, for example, an optical backbone. It could be an optical backbone with a lot of CPUs and storage in it. It could be a metro wireless network. It could be a sensor network. There are many, many different kinds of aggregates that are possible. but each one is kind of an autonomous system, right? It's autonomous, it's controlled by somebody, and in our view, it has a controller that actually, controls it, right? If somebody wants the backbone to be formed in this topology and these machines set aside, it's the aggregate controller that does it. Clearinghouses have a bunch of stuff in it, known research organizations, known and trusted aggregates, operations and management functions, policy. This is for cases like the NSF clearinghouse where scarcity is administered by policy rather than by economics, and so on. Here's kind of a guide to who's who and what's what. Currently, we believe GENI consists of a bunch of different substrates, and a substrate is kind of a physical instantiation, or it's a substrate itself is never really visible to researchers. For example, it might be racks of computers and switches and so on that are going to be configured in various ways and made visible to users. But they have to be managed and so on. So, that's an important part of the whole system. But kind of the researcher's view is a much more abstract view of resources that they can allocate and topologies they can manipulate. And then when they're all done, they get something that really is kind of like a very large distributed machine. Right? They're in their own slice. It's their own virtual world with their own CPUs, their own disk, their own connectivity, completely unaware of anyone else that's using the same infrastructure at the same time. And so right now we're kind of in the process, this is work going on at present, of, hey, if this is the conceptual framework, does it actually map onto things that people have proposed as parts of GENI? Can we do that mapping? And it seems to it. Some people want sensor networks and mobile ad hoc networks, delay-tolerant networks, part of GENI. Well, yeah, it looks like it's got all the right parts in the abstract architecture for that. Other people want national footprints with high-speed routers. Yep, probably can do that. Can we do a CPU kind of storage cluster? Yeah, we probably have the right moving parts to represent that. Ditto for the programmable routers people are coming up with, sliceable routers. So this is work in progress. Okay, and we're almost done. So how can you participate? And I hope you will. Number one, so join the GENI working groups and start doing the design. The GPO will help with the design, but really it's up to the community to do the design. And so if you think, boy, that was pretty sketchy, well, get to it. Okay, start creating the design. These are the current set of working groups. Earlier, the working groups are kind of factored by research interest area. You could think of them as kind of special interest groups. And this made them very kind of narrow and siloed. The wireless people never talked to the optical people. The computer people never talked to the wireless people. And in fact, when times got rough, everybody pulled out their knives and tried to kill off the other working groups. So we tried to refactor everything so that they do not line up with any research areas. Anyway, so these are the current set of areas. One of them that is of particular interest is how on earth do users opt in? I don't think anyone has the slightest clue how this actually is going to work. So if you have a clue, this area would be extremely helpful. Okay, second way. These GENI engineering conferences, you are cordially invited to show up. The room only holds, 175 people, 200 people, something like that. But the next one is March 3rd and 4th in DC. So we hope you will show up and just start driving this boat. Okay, and perhaps the most interesting way to academics, the sums of money are so astronomical, possibly even Microsoft is interested in these fabulous sums of money. But the GPO is actually going to solicit proposals. We still expect the solicitation to come out on December 17th. And we will be asking for a range of things, including small travel grants for academics to participate. We want to get prototypes up and running. We want to do trial integrations. And I believe we will have a lot of good proposals in each of those areas, actually. I've been going around talking to a lot of people, and I think I think there's going to be a fair number of really good proposals. Check out www.geni.net for the relevant details. Okay, and the end. So, my take is this. Nothing in life is perfect. So is GENI perfect? No, GENI is not perfect. Is GENI an opportunity? Yes. Yes, you could really, really make something out of this. So I would encourage you to think, what can we make that would be really fantastic? I think we're right at a time where there is an opening to do something real here. Right? The technology is changing in interesting ways. There is money available to make the seed of a pretty good system. So all pointed comments are welcome, but this is really a chance that we can exploit if we can get our act together. Okay, thanks very much. Now, questions?
How closely connected are you to the science office? And, it seems like you've got this independent charter to go off and figure out what this thing is and how to build it and all. But this oversight group seems, at least their charter in part, is to really explain the scientific plan and what all these experiments are going to be to justify this huge expenditure. Do you interact very much?
Yes, yeah. A lot, actually. There's a real chicken and egg problem here, that it's very hard for people to conceptualize what is the research, the world-shaking research that we want to do over the next 5 to 10 years. And, in a kind of a waterfall process, you would say, why don't you come up with that agenda for world-shaking research? We will turn that into requirements, and then we will begin to build. Well, I think if we did that, we would never get anywhere, right? So what we're trying to do is say, we're in the planning phase, right? Let's simultaneously build and try to figure out what we like. And this is going to be a somewhat messy process, right? We'll build some stuff, and it turns out nobody wants that at all. But I think this is a way to kind of jar people and get them thinking, okay, what is a good research agenda? So this is going to be going on in parallel. And
If I can comment on this, I'm on the CRA board.
Yep.
Nominally has oversight over CCC, which in turn has
Yep.
relationships with the uses like the hierarchy.
It's a Victorian plumbing system. Right.
Not to the GENI program office.
Right.
To all the other entities involved. And I think this is also being viewed as a prototype process for something that's been going on in other sciences for a long time.
That's right.
And
Yep.
that for which each scientific discipline has its own way of doing it. It doesn't work the same in physics and astronomy and chemistry. They all have their own history and culture for getting enough consensus to do these big money instrumentation projects. This is the first for computer
Right.
science, and some people obviously roll by the horns in spite of all the potential criticism and like and said, let's try it. And let's just see what we can come up with here. So this is a community effort. I mean, if the community just chooses to kind of stand back and kind of watch it from afar and see how it develops, and it isn't going to succeed for sure. It won't be the consensus that's required in order. People in Washington will figure it out that this is a few people trying to get a big check to build something for their personal pleasure.
Right, which is not going to happen. Right, that's not going to happen. Right.
On the other hand, even whether or not GENI turns out to be a great project to do, in terms of the science plan and all the experiments are, it's also an attempt to understand just what the problems are in computer science, given the culture that we have of actually developing consensus and understanding how to get what is actually a couple of dozen fields to actually talk to each other and each of them figure out just how they might play in this common sandbox. So it's easy to be skeptical, but it's going to take quite a few people in a lot of different computer sciences to be actively involved in this thing.
And computer science is very interesting, too, as it enters the big science arena, right, which this is kind of recognizably a big science thing, is it has such enormous industrial commercial implications, right? The tie between computer science and industry is so strong. When you build the next particle accelerator, it's not like there are 5 companies really, really interested or 100 companies really interested, right? And so I think it's going to turn out in an interesting way. None of us knows what it's going to be. But I do think this is a huge opportunity. So we should go for it.
If I could recharacterize some of the things you said in a manner of testing whether or not, well, how this fits. I mean, the following statement is not a criticism, but I'm going to phrase it as a criticism. I don't see any goals here.
Mm-hmm.
And I'm not saying that's wrong, I may be right. When the National Accelerator Laboratory was built, there were some specific experiments that they needed to work on, and they needed a certain amount of energy in the particles and so on. And I think it's arguable even in the earlier internet they were trying to solve some more basic problems. This is much more of a matter of if you build it, they will create. So it's kind of a laboratory looking for experiments.
Right.
You know.
Right. And my take is this: if you were going to wait for the world-shaking vision before you started, it would be a long time before you started. If you seize on this planning phase, 3 to 4 years, as a time in which we're going to simultaneously start doing things and try to have an idea, it will become apparent in 3 to 4 years. If there's no idea, that's that.
So in a
Right.
sense, your metaphor is the Oklahoma land run or the population of the Midwest of the United States, where they had this open land, they sent out some surveyors, and they said, okay, we're going to give 20% to the police, we're going to give 20% to this is the land, to the railroad, 20% to the municipalities. Go. Is that fair?
I like the analogy. I mean, you know, my mental model is most of the people in computer science cannot think unless they have a screwdriver in their hand or are typing, right? To ask them to stop and think is really hard, but to ask them to, you know, go for it, right? People will go for it. So.
Do you think this is like the second alphabet? Do you think this is like the second alphabet?
You know, obviously we're hoping to have a huge success, right? It's quite different from the ARPANET in that there's an enormous industry right now, right? There are many, many different technologies and many, many different parts of industry. So I think right from the beginning, rather than have one company build and operate it, it's going to be very, very different. But I do think it has that potential, if somehow we shape this right, of becoming a real kind of quick takeoff success. Knock on wood. That's what we very much want.
Can you give some numbers during the planning phase? How many devices, routers, fibers? Just what you think about it.
No.
Okay.
No. Okay. So here's what I want, right? In the next 6 to 12 months, we have $7.5 million, right? What is the biggest possible splash we can make? What's the most productive use we can make of that $7.5 million? Well, you probably have a lot better ideas about parts of that or about all of that than I do. So what I want to do is I want to get competing teams who are trying to think of how could I just kind of blow the top off other people.
But you are thinking about pushing bandwidth and router speeds and things like that in this installation, I assume.
Well, you know, we're not trying to tell people what speeds they want to run at, right? But there are multiple groups that are doing pretty darn high-end things, and I'm pretty sure they're going to bid. So this is not, you know, Mother GPO knows all, lays down requirements on everybody. This is, you know, so what can you do that's a lot better than what other people can do? And then if people like it, we'll do a lot more of that.
So you think about having a certain amount of dollars, and what is the right amount of dollars to think about? You said $7 million, but that's...
Right. If you go on the GENI.net site, so we break it out under the first GENI Engineering Conference. There's a pretty detailed breakout of how many efforts we expect to fund in certain categories and the range of money. And I can't quite remember it in my head, but it's hundreds of thousands of dollars. This is not a lot of money. I think if we start to demonstrate success, we can probably get some more money. But this is a thinly funded project.
What is your, I mean, I guess my question to get funded now, as opposed to this is really good, but there's no point in funding it because it doesn't get us to the next.
Right. Well, we won't fund anything that we don't get good solicitations in, right? So if you or somebody else doesn't put in a good solicitation, that isn't going to be there in this first 6 to 12 months. But I believe we will get great solicitation or great proposals in, kind of high-end optical networks, racks of computers or storage, metro wireless of various varieties, sensor networks, maybe cellular. Right? I think we'll get all those areas in the first 6 to 12 months. I hope we get a lot, I hope we get some things we haven't thought of, right? But
I mean, I do realize you want to be very hands-off, but I think there is room to be a little hands-on too. I mean, especially when you're trying to shape it in the early phase. It's
Yep.
like a baby trying to get up,
Yep.
and you want to say, just get up.
Yep.
I mean, so I think there's a little bit of that has to happen in terms of trying to mentor the process.
right. So let me be a little more specific. So what you might do, just to put thoughts in your head, is you might find one or more academic partners that you enjoy and think of an aggregate you could build. Now, the whole control structure is currently rather poorly defined, undefined. But an aggregate might be a wireless city area. It might be kind of a storage thing, or, right? Think of an aggregate you could build and operate. Put aside a Linux computer or, Microsoft computer or two, into which people can put a control framework when that becomes available. But we know it won't be available in the next 6 months, right? And demonstrate that, look, remotely users could actually pour code into this, operate it. There's a possibility of getting real users in this. I think if you did an aggregate, that would be something manageable, self-contained. You could run your own existence, right? And it would be a big help.
Following up on that, I think a brilliant thing about the way you designed this is basically forcing the academics, or us, the research community ourselves, to organize, find groups of us that can work together and put together these things which then are cohesive wholes, rather than a whole bunch of independent technologies being thrown
Well,
at
this is a daring leap, Dave. We'll see if there's even one team.
But yet, I find myself in possession of a technology for management food things. It seems to cross-cut
Right.
Several of these layers.
Right.
And yet, so I'm making phone calls to lots of different
Right.
people trying to say, hey, can we get this idea? Can we integrate it in with your thing and with your thing?
Yes.
And with your thing? 'Cause
Yes.
we don't know who the winner's going to be. Or,
Yes. So that is a recognizable other class of prototype, right? You've successfully hit upon a very core area of GENI, which is the management, configuration, troubleshoot, it's like that whole part of GENI. That one you could safely, bid as a standalone. Well, not quite safe. It's a little shaky to do that. And then attempt to integrate it as we see, what actually gets proposed and what gets funded. Try to integrate it with them. Remember, we have $7.5 million a year, right? I mean, one simple thing you could do is wait a year, see what's there, and then try to create a proposal. But I think actually the proposals are pretty short, pretty lightweight. You could actually try to make a proposal, but then you'd have, the parallel integration problem, right? But that would be extremely helpful. That level of thing is clearly required, right? There is, as yet, no good story. So.
This sounds like the biggest, most ambitious, multi-headed DARPA broad agency announcement I've ever heard. It's like a
Great.
BAA.
I guess it's like a BAA, right?
And multiple dimensions.
Right. Yeah. I think my guess is, so, we have to get out of neutral into first gear. And I've been teaching my daughter driving in our standard, and, we're kind of getting into first gear here. The first 6 to 12 months, I believe, we'll see, things are not going to really integrate, right? I mean, people will produce X, people will produce Y, we'll try to cobble them together. They won't. They might marginally be cobbleable together, maybe not. But that's when we go, what we need is this. And, you almost have it, and this over here, right? So this first 6 to 12 months is to get us into first gear and allow us to have the really important thoughts about, okay, now we know what we need. So perfection is not required, right? We got like 3 to 4 years. We're in the planning phase, right? So this is the first year of the planning phase. We're not building this. We're trying to have the thought.
It almost sort of seems there are two questions. One is that the people who win the award the first time, by default, you probably need to have them give an award next time too. Because I mean, you're going to build something, and if you're looking at these things that don't really fit, and how can you do this without their involvement anymore?
Well, not to be too mean, Victor, but this is the kind of thought you would have. But if nobody is really very interested in what they've produced,
I'm particular with
there would be people who produce things that actually nobody really is very interested in, and we're not going to keep funding those things. So even if they succeed, if it's not of great interest to people, thank you. That was very nice.
And what about the policing part of all this? You give some money, and then how are you going to make sure that progress is made?
Right. So, there's only about 5 or 6 of us in the GPO. And what we're going to do is we're going to take system engineers, right, and say, I want you to ride shotgun loosely, right, because the amount of funding is so small. This is not a very intrusive process. But we want you to show up every 4 months and explain, well, have you done it? What's up and running? Where are you? Right? And in the extreme case, if, time after time goes by and people haven't done anything, we'll just shut them down. So these are not NSF grants. These are subcontracts. Yeah.
Yeah, I just want to try to get more clarity on what exactly it is you're trying to build. It seems like you say GENI itself is not supposed to be scalable.
That's correct.
So
GENI.
You're building more of a distributed systems test bed than a networking test bed.
Well, I view it, I have a very Big Ten approach. I view it as all the same. This is a test bed in which programmable communications, computers, storage, it's all in play. Everything from programming RF waveforms up through application programs.
So is GENI supposed to provide if it's not an experiment, I would assume that to do this control, you have to have some control plane that is not being mucked with by the experiment.
That's correct. That's correct.
So
Yes.
There's going to be the ability to set up your own different data planes that are
Yes.
really multiple.
Yes. That's the notion of the slice, is that we will basically give you virtual machines, so you can't go outside of this little sandbox, right? Here is your machine. Here is your connectivity between machines, right?
If you're interested in, for example, things that would depend upon the capacity of the underlying network.
I'm sorry. Give me an example.
For example, people do things on Planet Lab where the whole point of doing them on Planet Lab is that they're actually on a live internet
Yes.
and they can see what kind of congestion control
Right.
they're getting, or how well the routers are
Right. I think the chances are 100% that will be supported. Right. There are all different layers at which you can interconnect things. And so part of an experiment setup is to say, hey, just give me IP connectivity between here and here through the internet. Just give me IP connectivity on a dedicated link, right, where I don't have any contention. Give me MPLS. Give me, right? Yeah, right. So at many different layers. So some researchers, they really do want the channel in between to be the live internet, and that almost certainly will be supported, for sure. Because, there's a large group of people that wants that.
So what that means is you're hoping to be able to do experiments both within the internet, in the sense of applications layers and all that stuff, down to, let's say, the routing layer, and then work on next generation internet protocol. Because, Vinsurf, Bob Connor out there telling everybody we're out of gas. And in some ways that we are, and we are.
Yeah, right.
But certainly if we could find some ways to handle security and scaling and some other issues.
Right.
We'd be happier. So this is a domain in which you think we can experiment.
Right, right. I mean, if our job, let me push back slightly. If the GPO's job is to create a complete replica of the internet inside GENI, we don't exactly have enough money to do that. That requires hundreds of billions of dollars. But if it is things like, and let experiments run through the real internet, yeah, we can certainly do that.
So if I want to experiment layer below routing layer. I just want to, for example, transport layer protocol, application layer research. Why do I need to use GENI? I can just use Clearinghouse and do the same thing.
That's fine. I mean, right.
I mean, why this is important?
Well, let me give you a little challenge. So, you know, possibly for some research, right? You don't need GENI. Certainly agreed, right? And the same is true in wireless land. A lot of people do specific research that they don't need GENI to do. But allow me to say, suppose what you really want to do is figure out, how do I do high-capacity distributed systems, right? Where, say, I had 10 gigabits between my computers and real users running all through Seattle, right? If what you want to do is stay inside the Planet Lab view, you should stay inside the Planet Lab view. But if you want to see, oh, things could be really, really different if I had, you know, incredible dedicated bandwidth, which actually you will have in a couple of years, right? That would be something to do. And if you want to have, say, wireless or users, good. But nobody's going to kick anybody off Planet Lab, right? I mean, that Planet Lab will continue to exist, I'm sure.
You're going to meet with him later, so perhaps by the 2:10, because he's taking a break and he's got like, oh, okay, so we'll just wrap it up here.
Okay, thank you very much.